Thank you for watching. Hi there. Evaluate the following, and we are doing part A, 2 sine 15 cos 15. We are going to be using the concepts of the double angles to solve these. There are very many methods for killing a rat, just like I already said, but this time around we shall kill it this way. So you realize that 2 sine 15 cos 15, once we split it up, we shall obtain sine 15 cos 15 plus cos 15 sine 15. It's the same thing, just that we are making it look familiar to what we know already. Once you look at that expression, it gives you an impression of the very first double angles we looked at, sine 15 plus 15. And once you add 15 plus 15, you of course get 30, which is our final answer there, the sine of 30, which is a half. Number 2 says 2 tan 22 and a half over 1 minus tan squared 22 a half. And so we also make this one look familiar to what we have been using, such that it is easier for us to evaluate. And so you observe that the upper one can be split into 2, which is tan 22 and a half plus tan 22 and a half over 1 minus tan 22 a half tan 22 and a half. And so once you continue down there, you realize that this is so familiar to us, and it is simply a double angle. So we add up the angles, which is 22 and a half plus 22 and a half, which now gives us a tan of 45. But remember, tan of 45 is equal to 1. Then we shall be continuing. I'm moving a little fast, so please cope up with the speed. We are going to our example 2, and they've given us sine theta being equal to 3 over 5. And they are telling us to solve for sine 2 theta when we have been given sine theta is equals to 3 over 5. Remember, I told you in trigonometry we build concepts. Watch carefully as we build on this. So we split up our sine 2 theta, of course, because we want to replace for sine theta, and we obtain the first equation. I hope you are familiar with that. And so once you know this, it is easier for you to just know that sine 2 theta is the same as 2 sine theta cos theta. So we have a cos theta in our equation, but we do not have the value for cos theta. What do? Very many methods of doing this. I will only exploit 2 of these. So you'll observe that sine theta is equal to an acute angle, which is 3 over 5. So if our angle there is theta, then the opposite is 3 and the hypotenuse is 5. Once you use Pythagoras theorem, you'll obtain b as 4, and b is our adjacent. And therefore, we can now state the value for cos theta, which is 4 over 5. I'm having some bit of flu, but please excuse me for that. Or the second way of doing this, we can say that from the trig identities, you remember the trig identities we derived from the triangle, sine squared theta plus cos squared theta is equal to 1. So if you want to get cos theta, then we make it the subject by taking over sine and getting the square root. But remember that sine is equal to 3 over 5. So once you replace for sine theta inside there, you obtain that particular equation, 1 minus 3 over 5 squared, and then we apply the square root. Then finally, cos theta will now be equal to, once you get simple algebra there, the LCM there is 25. So 25 times 1 is 25 minus 9, which now gives you 16 over 25, and apply the square root. I know most of you at this moment you now say the square root gives us a positive and a minus. That is true, but in this case we consider the magnitude. So cos theta is equal to 4 over 5, the same expression we got by mere using the triangle. Whatever is easier to you, please do that. So we can now replace for sine 2 theta, and wherever there is sine theta you put 3 over 5, and wherever there is cos theta you put 4 over 5. Once you evaluate that, you obtain our final answer, 24 over 25. Thank you.